In this last video for Unit 4, we're going to look at graphing polar equations. And here's a summary of some polar curves. We're going to reference this chart, but really what we're going to do is we're just going to start creating tables of values to graph these polar curves. But if you do recognize some of these things, and I'll talk about them as we go through some examples, there are some characteristics of a polar equation that can help you identify what the graph will end up looking like. So our first equation is r equals -3 sine theta. So if we look at this summary of polar curves, -3 sine theta, that looks most like the equations for a circle. So we're expecting this to look like a circle. Again, identifying what it should look like in advance is really just going to help make sure that you're on the right track. But that doesn't mean that you necessarily need to go through this step as long as you're going through your ordered pairs correctly. So our table of values, we're used to this XY table of values. Our input or our independent variable is going to be theta, and our dependent variable is going to be r. So we're just going to start plugging in values for theta. Now I'm going to use the polar curve that I have, or the polar grid that I have. The polar grid that I have has our quadrantal angles and those multiples of 30 and 60 degrees. I'm not going to plot points of 45 degrees just because I don't have a nice grid mark to help me identify where that's going to go. Doesn't mean you couldn't do it. I'm just going to opt not to. So I'm going to just start with 0 degrees. So I'm going to use my angles in degree measure. This can also be done in radian measure. So then r is equal to -3 sine of 0 degrees. Sine of 0 is 0. So at 0 degrees, we have a point of 0. So we're going to plot to that point 0, 0. Then we're going to go to our next angle of 30 degrees. So this is -3 sine of 30 degrees. And sine of 30 degrees is 1/2. So this is -1.5. So if I go to my 30-degree angle, we're going to have to use that reflection. Remember, with polar coordinates, when your radius is negative, we're going to end up with a reflection. So I'm going to plot a radius of 1.5 and 30 degrees. So that's like right here, but then it's going to be reflected. So our next point's actually going to be down here. And what we're going to do is we're just going to connect those 2 points with a nice curve. Okay, I'm going to erase that because I can easily. Now let's go to 60 degrees. So -3 sine of 60 degrees. That's -3 times the square root of 3 over 2. And I'm going to use a decimal approximation for this just to help me approximate the radius. That's going to be -2.6. So again, I go to 60 degrees and 2.6, which is maybe right there. But then I'm going to reflect it about the origin. So there's that point right there. You can see I've just added it. We're going to reflect this about the origin to get our next point. And connect those 2 points. Go to my next angle of 90 degrees. -3 sine of 90 degrees is -3 times 1 or -3. So I start at 90 degrees and a radius of 3, and then I'm going to reflect that, connecting that point. And I'm going to continue on this process. Now, one point I do want to make is I am recalling these trig functions from our unit circle very quickly. If you don't know your unit circle as well as I do, that's okay. But the more you use it and the more you're trying to recall these function values, from memory, the easier it's going to get. Our next one's going to be 120 degrees. I'm just adding 30 degrees here every time. Because that's how my angles are divided up in this polar curve. So -3 sine of 120 degrees is equal to -3, and sine of 120 degrees is the square root of 3 over 2. So this is that -2.6 value. So if I go to 120 degrees and 2.6, I don't know, that's about there. And then I'm going to reflect it because that radius was negative, which puts me about here. And I'm connecting the points you see as I plot them. 150 degrees is our next measure of theta. -3 times sine of 150 degrees is -3 times 1/2, or -1.5. So at 150 degrees, we're at 1.5. And if I reflect that about the origin, it's about there. And then 180 degrees, -3 sine of 180 degrees is -3, and sine of 180 degrees is 0. So this is 0. So that's going to take me here. So it's not a perfect graph, but you can kind of see, and it's a little bit harder because we are drawing those segments as we go. But if we were to just connect these points, we would get that nice, oops, that was not better. This nice circle. And then if we continue to add more angles of theta, what we're going to see is that process repeat itself. All right, our next equation is r equals 3 cosine of 3 theta. So let's go back to that summary chart and see which equation looks closest to that. So it was 3 cosine 3 theta. If we look at those equations, it looks like these two rose curves options are the closest to that original equation, or that equation we're given. And since n is odd, it looks like it's going to be a rose curve with an odd number of petals. In particular, n petals. So we expect this to be a rose curve with three petals. Again, using my angles in degrees, I'm starting with 0 degrees. This is going to be 3 times cosine of 3 times 0 is still 0. And cosine of 0 is 1, so 3 times 1 is 3. So this graph begins at an angle of 0 and a radius of 3. $30 degrees, that's going to be 3 cosine of 3 times 30, or 90 degrees. Cosine of 90 degrees is 0, so this is 0. So at our angle of 30, the radius is 0, so we're starting from that first point, connecting to that second point. $60 degrees be 3 times cosine of 60 times 3 is 180 degrees. Cosine of 180 degrees is -1. So at 60 degrees and a radius of 3, now we're going to reflect that about the origin. So that puts that point there, and we're connecting now from that second point to this third point. theta of 90 degrees, we've got 3 times cosine of 3 times 90 is 270 degrees. Cosine of 270 degrees is 0. 3 times 0 is 0. So at 90 degrees, that radius was 0, putting another point at the origin. So now we're connecting back to the origin. (120 degrees). We have 3 times cosine of 120 times 3 is 360 degrees, which is 3 times 1, or 3. So at 120 degrees, our radius is 3, which is right there. Connecting from that last point, which is at the origin, to this new point. 150 degrees, this is going to be 3 times cosine of 3 times 150 is 450 degrees. And it's going to be easier for me to think about this as a coterminal angle. So I'm going to subtract 360 from 450. So this is 3 times cosine of 90 degrees. Cosine of 90 degrees is 0. So now at that angle of 150 degrees, we're back at 0. So now we're going to go there. And then let's add 180. This is 3 times cosine of 540 degrees. 180 times 3 is 540. Again, looking for that coterminal angle by subtracting 360. This is the same as 3 times cosine of 180 degrees. And cosine of 180 degrees is -1. So this is -3. So if I think about the angle 180 and a radius of 3, that gives me a point right here, but then I need to reflect it, which is going to take me back over here. And if I'm connecting those points, I end up there. So we're following this pattern of graphing these points in a particular order as we increase our angle of theta going around the unit circle. And we're creating these really pretty curves. These are one of my favorite graphs to make. All right, the next one, r equals 2 plus 2 sine theta. So let's go back to that chart and see which ones look like 2 plus 2 sine theta. It looks like all 3 of these graphs have that form, okay? So now we want to look at some of these extra requirements. For a cardioid, we're going to have that a over b is 1, which means that a and b are equal. And that a and b are the coefficients. So looks like we're going to be dealing with a cardioid in this graph. All right, starting with 0. We've got 2 plus 2 sine of 0 degrees, which is 2 plus 2 times sine of 0 is 0. So this is 2. So our first point, 0 degrees, our radius is 2. Plugging in 30 degrees, 2 plus 2 sine of 30 degrees. It's going to be 2 plus 2 times sine of 30 is 1/2, which is 2 plus 1 or 3. So at 30 degrees, my radius is 3. 60 degrees, we have 2 plus 2 sine of 60 degrees. which is 2 plus 2 times sine of 60 is square root of 3 over 2. And again, I'm going to use a decimal approximation for this just so I can sketch that point. 2 plus the square root of 3, since those factors of 2 cancel out, is 3.7 approximately. So at 60 degrees, we're at 3.7, so a little bit closer to that radius of 4. (90 degrees), we have 2 plus 2 sine of 90 degrees. Sine of 90 degrees is 1, so this is 4. So at 90 degrees, my radius is 4, and I can go ahead and start connecting these points. I hadn't been doing that. Okay, we got to keep going. 120 degrees, 2 plus 2 sine of 120 degrees is equal to 2 plus 2 times sine of 120 degrees is square root of 3 over 2. And that's going to be 3.7. (150 degrees). 2 plus 2 times sine of 150 degrees is equal to 2 plus 2 times 1/2, since sine of 150 degrees is 1/2. And this is 3. (180 degrees), 2 plus 2 sine of 180 degrees. Sine of 180 degrees is 0. So this is just 2. Again, connecting a few more points. Since we haven't closed that loop, we do want to keep going, keep adding more angles to our table of values. Our next is going to be 210 degrees. 2 plus 2 sine of 210 degrees. 2 plus 2 times negative 1/2. Sine of 210 degrees is negative 1/2. And this is 1. So now we have this point even closer to 0. So if you can kind of see where I'm going there. Next, you've got 240 degrees. Two plus 2 sine of 240 degrees is equal to 2 plus 2 times negative square root of 3 over 2, which is 0.27. So I'm going to zoom in real far just so we can see at that 240 degree, our radius is about 2.27. So we're starting to kind of come in. (270 degrees). 2 plus 2 times 270 degrees is equal to 2 plus 2 times negative 1, which is 0. So now we have another point of 0. So now we've made our way to the origin. We still haven't closed that curve, so we're still not done. (300 degrees). 2 plus 2 sine of 300 degrees is equal to 2 plus 2 times negative square root of 3 over 2, which is 0.27. So that's a point approximately there. So now we're starting to kind of make that like cusp here. It looks like we're heading back to that starting point. 330 degrees. And I'm guessing we're going to have to go all the way to 360. So maybe we finish off the table of values and then plot those last 2 points at the same time. So 330 degrees, that's 2 plus 2 sine of 330 degrees which is 2 plus 2 times -1/2, or 1. And then plugging in 360 degrees, 2 plus 2 times sine of 360 degrees is equal to 2 plus 2 times 0, or 2. So at 330 degrees, we were at 1. And then at 360 degrees, we were back at 2, which takes us back to the beginning. And there's our cardioid. All right, so definitely a lengthy process creating that table of values. We're going to go through one more. R equals 1 minus 2 cosine theta. So let's look back at our chart. Identifying these values of A and B are 1 and 2. Because this looks still a lot like one of the equations for a cardioid or a limaçon. Limaçon, I think that's how it's pronounced. It's a French word. So we know it's not a cardioid because A and B are not the same. But we do know that A is less than B. So it looks like it's going to be this type of inner loop limaçon, where it's the inner loop is sort of on that horizontal axis versus that vertical axis. But again, we're going to plot the points and see how it turns out. This is just a technique of just making sure that we're on the right page or on the right track. All right, so let's start making our table of values. I'm going to go ahead and fill in all my angles for theta. Maybe I won't need all of them, but maybe I will. So I'm just going to go ahead and start filling those in if you want to go ahead and pause the video and do that yourself. All right, so let's start plugging in our angles for theta. So theta is 0 degrees. That's 1 minus 2 times cosine of 0 degrees, or 1 minus 2 times 1, which is -1. So I'm going to go to 0, 1, and then I'm going to reflect about the origin, putting my first point over here. 1 minus 2 times cosine of 30 degrees is 1 minus 2 times the square root of 3 over 2, which is approximately -0.73. So again, starting at the angle 30 and a 0.73 radius. So about there, now we're going to reflect that over the origin. Plugging in theta equals 60 degrees. 1 minus 2 times cosine of 60 degrees is equal to 1 minus 2 times 1/2, or 0. (90 degrees), 1 minus 2 times cosine of 90 degrees, which is 1 minus 2 times 0, or 1. So connecting the 4 points we have so far, looks kind of like that. Let me zoom in a little bit more to show that. Like that. Okay, back to our table of values. 120 degrees, 1 minus 2 times cosine of 120 degrees is equal to 1 minus 2 times -1/2, which is +2. Let me make that a little more clear. This is a -1/2. So at 120 degrees, we're at a radius of 2. 150 degrees, 1 minus 2 times cosine of 150 degrees is equal to 1 minus 2 times negative square root of 3 over 2, which is approximately 2.73. Plugging in 180 degrees, 1 minus 2 times cosine of 180 degrees is 1 minus 2 times negative 1, or 3. So let's zoom in on our graph and connect the rest of our points. So starting from that last point that we connected, we're going to go through the other points we just added. So we're starting to see sort of a spiral. 210 degrees, 1 minus 2 times cosine of 210 degrees is equal to 1 minus 2 times negative square root of 3 over 2, just 2.73. So 210, we're at 2.73, about there. For 240, 1 minus 2 times cosine of 240 degrees is equal to 1 minus 2 times negative 1/2, which is 2. You're noticing hopefully a lot of repeated values, and that's going to be pretty common with a lot of these polar curves. Theta is 270 degrees. 1 minus 2 times cosine of 270 degrees is equal to 1 minus 2 times 0, or 1. Okay, I'm going to connect these points together over here, starting from that last point we connected. Okay. Since we still haven't finished, good thing we put all these angles from 0 to 360 on there. Let's keep going. 300 degrees is 1 minus 2 cosine of 300 degrees, which is 1 minus 2 times positive 1/2, or 0. So that takes us to that origin again. 330, 1 minus 2 times cosine of 330 degrees is equal to 1 minus 2 times positive square root of 3 over 2. Cosine is positive in the fourth quadrant. And that's negative 0.73. So again, thinking about at an angle of 370 or 330, we're at negative 0.73. So that's about there. Let me redraw that for you guys. Here's our angle of 330 and our radius of 0.73. Now we're going to reflect that since that radius given to us was negative. So it's going to be about there. And then 360, 1 minus 2 times cosine of 360 degrees is equal to 1 minus 2 times 1, or negative 1. So again, we're going to graph 360 degrees and 1, which is going to be right here. We've already graphed a point there, and then we're going to reflect it, which is going to take us back to that starting point. So those last few points that we're connecting are going to go like this. So definitely a lot of work, but great practice in using those trig function values from our unit circle.